Hello everyone, we are the students of BTech first year from Department of CSE AIML Section B, and my name is Manyata Chatterjee.
My name is Pooja Kumari.
My name is Shantona.
My name is Abbas Kumar.
My name is Anurag Kumar.
My name is Rajil Khan.
This is Group 2 and we are conducting an experiment on hollow prism and calculating the refractive indices of different mediums. Thank you.
The experiment are arranged together. These include a cardboard base, a hollow prism made using glass, a monochromatic light source in the form of a laser, and different transparent liquids such as water, kerosene, and soybean oil. We now begin assembling the experimental setup. The cardboard sheet is used as the base, providing a flat and stable surface. The components are carefully positioned and fixed in place using glue and adhesive materials. Proper alignment is maintained to ensure that the laser beam travels in a straight and well-defined path. This step is important because even small misalignments can affect the accuracy of the observations. Once the setup is complete, a reference line is drawn on the cardboard along the direction of the incident laser beam. This line represents the original path of light and serves as a baseline for measuring deviation. The experiment is now started by filling the hollow prism with water. Care is taken to ensure that the prism is completely filled and free from air bubbles. The laser beam is then passed through the prism. As the light enters and exits the prism, it undergoes refraction, causing a deviation from its original path. The emergent ray is traced on the cardboard and the angle of deviation is observed. The angle of incidence and the angle of deviation is measured using a protractor and the values are noted down. Refractive index is calculated using the formula sine of angle of prism plus angle of minimum deviation by 2 by sine of angle of prism by 2. After completing the observation for water, the prism is emptied and cleaned and then filled with kerosene. The prism is rotated to accurately find the position of minimum deviation. As soon as the laser beam passes through the kerosene-filled prism, the change becomes clearly noticeable. Compared to water, the laser beam bends much more in kerosene. The emergent ray shifts farther away from the reference line, making the deviation visibly larger. This happens because kerosene is optically denser than water, meaning light travels more slowly through it and bends more while entering and leaving the prism. The angle of incidence and angle of deviation are again noted down, and consequently, the refractive index is found. As we can see, it is significantly greater than water. After the kerosene observation, the prism is once again emptied and carefully cleaned. It is then filled with soybean oil and the laser beam is allowed to pass through it. At first glance, the deviation observed in soybean oil appears comparable to that of kerosene, but on closer observation, it is found to be slightly less. The emergent ray in this case lies a little closer to the reference line than it did for kerosene, indicating a marginally smaller angle of deviation. The angle of deviation is noted and the refractive index is calculated. Thus, the hollow prism experiment successfully connects theoretical concepts with practical observations. Thank you.